Hello, everyone. This is Eric. I'm here to record the video for week 7 data. There were some video problems with Sabrina, our other instructor, who actually planned all this out for you guys. Unfortunately, she ran into some software issues and the video came out very low resolution. So I'm just stepping in for this week. I'll just be going over the assignment along with just some of the basic concepts surrounding pandas, the data manipulation sort of framework / library within Python, along with a short intro to Markdown. And I will get you guys started with the first, I guess, subtask of our assignment for week 7. So from what I understand, even though the due date was shifted to this Friday, since the video is probably going to be out tomorrow, so Thursday for me. By the time you're watching this, it'll probably be Thursday. The due date will most likely be next Friday. 99% sure about that. So let's get started. I will first go over the notebook sort of area that you'll be doing your work in. This is the example.ipynb file that you can find in this Google Drive folder. And this Drive folder is linked here at this link. So what I just did is I double-clicked on it and I had installed Google Colab on my Drive account previously before this. So if you don't see this little open with, you're going to have to do that on your own Google Drive account. There should be some sort of button saying to install other apps to open this file type with, since Google Drive doesn't come with Colab installed automatically. So you have to install that. It's not too difficult. As always, Piazza and the Discord is available for your help. But I simply clicked this and it opened over here. And now I can start going over just sort of this environment. It's pretty simple. If you've been coding in Python, you'll immediately recognize it. A lot of it is just made up of code blocks where you type in Python as you normally would. And then you also get other sort of blocks where you can type in text. And the text just sort of happens to be read in as Markdown by the Colab environment. And what Markdown is it's simply, you can think of it as kind of another programming language, not really. See, I say programming language because if I double click on that little text portion to edit it, you'll be able to see sort of the behind the scenes of it. If you look at the right, this is what the Markdown is rendered to. On the left is what that raw text looks like. So you can see sort of the relationship between, say, this line, where you have a pound symbol or a hashtag, and then the word text, and then within parentheses, double click to edit. And then over here, you have just the text. You don't see that hashtag or pound symbol. But you'll notice that this line is a lot bigger in terms of its font size than the other lines over here, right? And you'll notice that, say, these 3 lines that are preceded by the 1, 2, and 3, it's sort of indented. So what Markdown essentially is a way to sort of write plain text, but sort of surround your text with certain elements like hashtags or numbers with periods after them to denote a list, or in this case, backticks, right, to denote some sort of code. And essentially, it gets fed through what's called a Markdown interpreter, pretty much like a Python interpreter, that looks at this text and just spits out the rendered version, the nice, pretty version. So this is kind of what we want you to get used to. Markdown is also what GitHub uses for their READMEs. You'll notice that in a lot of the READMEs that you write, you'll have some header with a hashtag at the beginning to indicate a sort of heading line, a sort of big font style. And then what you can do is you can prepend additional hashtags to essentially have different sizes. So if I have, say, 3 hashtags, then you can see it progressively gets smaller, less pronounced. And these can be just good for section headings, right? So that's pretty much the basics of Markdown. You can sort of play around with things. Some basic Markdown, I guess, techniques/tips would be to use underscores for italics. Now you see the Colab environment comes with a lot of handy sort of buttons, right? So if I just type in text and then I highlight it and I click this B button for bold, you can see it surrounds it with 2 asterisks. And 2 asterisks is what is used to denote a bold text. And then you'll notice that even though I have a new line separating, or even though I have this underscore ASD on a new line, in the actual preview, in the actual rendering, they appear next to each other. And that's because the actual new line sort of character over here, or the actual presence of a new line, is in itself a Markdown sort of object, right? So you want to make sure if you want to separate, say, paragraphs, that you do put in that new line there, right? You don't want it to just be sort of below it, right? Otherwise, you just get it next to each other, which you don't want. So that's sort of the basics of Markdown. Let's just quickly go on to the actual Python portion in the data manipulation. You can see what we're doing here is we are calling some methods on a PD sort of object. And PD stands for pandas. And pandas comes from this line over here where we're importing that library. Now, if I just quickly Google pandas, you can see it is a fast, powerful, flexible, easy to use open source data analysis and manipulation tool. There's a nice book there. Don't worry about getting it. But what's great about this website is that it has a nice user guide here, which you can and should feel free to look through if you want. However, what's a lot more useful for me anyway, when I just want to sort of get a understanding of how to use certain methods, right, is just click through the reference. And using this reference, I can just sort of look through and look at the method names or the function names and sort of kind of figure out, okay, yeah, if I have a CSV, I'll probably want to use, read CSV here, and it gives me a nice description. And then if I scroll down, hopefully it gives me some examples of how I can use it. Yep, over here, pd.read CSV. So you can see a lot of these libraries have great documentation that you can just look through. And of course, searching. But what I also love to do is just go over here and just search like pandas, how to, and then you get a lot of suggestions here, how to delete a column. And then you can obviously go to Stack Overflow. So this is the sort of process that we would want you students to go through as you're going through this activity. So let me just look through here. We have some demonstrations of certain methods we can do. So after we have loaded in the actual CSV file, which I'll show you how to do when we get to the activity, just giving a sort of overview here. You can see that we have the CSV loaded into a Python variable, and then we can sort of access individual column names, right? So type 1 is a column name within the Pokemon.csv file, and we can use the .unique method on that Pokemon CSV object indexed at that column name, right? .unique, to essentially get the unique values of, well, whatever column this is, and this is a type 1 column. If we have an N in front of that unique, we get the number of unique values. Pretty nifty. We can get the medium of things, and this is really cool. where you can sort of create a Boolean expression, right? So Boolean expression is any expression that evaluates to either true or false. So in this case, we are comparing our Pokemon CSV indexed at that HP column. So we're only getting the HP values. And we're checking if it's greater, if all those elements, if any of those elements are greater than that median we just calculated here. And this is stored in a variable called criteria. Now, we can't really do anything with just criteria, right? We need something to apply that criteria to. And you can see we have stored in this above average variable that Pokemon CSV object again, but instead of indexing it at a specific column name, we're not really indexing it. We're applying this criteria. And this will make it so that we sort of filter out, right, anything at which the criteria or that Boolean expression evaluates to false, and only get the stuff that evaluates to true, aka the Pokemon whose HP is greater than the median. And you can see here, if we look at the HP, 80, 80, 78, 126, 108, and if I just run, say this line, now I'm pretty sure if I run it, I'm going to run into an error. And I'll show you why. Yep, so we get an error, and the error type is a name error. It's saying that Pokemon CSV is not defined. And this is sort of a classic kind of pitfall that I ran into, and I feel like a lot of you students are going to run into as well, which is when you're running a certain code block that's like below other code blocks and which depend on variables declared in previous code blocks. You need to have ran those blocks before you run this one. Because obviously, Pokemedian, well, to us, it may seem like, in this case, Pokemon CSV, to us, it might seem like it exists, right? We have it up here. We have it here. We've declared it here. But to the actual environment, it doesn't exist because we haven't run these code blocks. So what we have to do is we can either go through manually run each one, just take a while. If you have a lot, right? Let's say you're all the way down here. Or we can simply select the code block that we meant to run in the first place, but got an error because we didn't run all the others before. And we can go over here to runtime and then simply click on run before. And that's just simply going to run all of the lines that came before. Now you can see we got another error, no such file or directory, right? And this is coming from that very first code block. So there's really nothing up here that we can do, right? I mean, import, all those import statements should have worked. Variable should have been declared, like that's all good. Error is talking about the actual files. So that's what I'll get into over here in the actual activity. So this notebook, right? This notebook you guys can access over here. Here is a weekly assignment on Google Colab. So if you just click this link, you'll find yourself over here. Now, what you want to do is most likely you want to copy this, right, to your drive. Because right now, I'm assuming this is going to be hosted in one of the instructor's drives, probably Sabrina's, since she was the one that created everything. So let's copy this to our drive. Open that new tab. And you can see, okay, cool. So now we have a copy. I'll just rename it to Eric's, right? Because that is my name. And then if I just locate this in my drive, where is it? So it seems like, cool. Google Drive made its own folder for me called Colab Notebooks. So it should have done the same thing for you. If you go to your drive, you should see a new folder named Colab Notebooks. And that copy of the workbook, right, that Jupyter notebook should be in there. Okay, so now that we did that, let's go through the actual importing of the files you need. So I'll just run this code block so that we get all of the libraries we need. We're going to be using Pandas mostly. Matplotlib is going to come in soon. I don't think there are any tasks for you to. Okay, let's see. Yep. So you do want to make a graph here. So that's good. We are going to be using matplotlib, and then NumPy might come in handy, might not, but looks like the code block ran. We had a lot of requirements already, so that's good. Now let's go back to trying to import our actual files. The command to do that is pd .read underscore and then whatever file type we want, right? So first file type we're going to be dealing with is the CSV. And I just know off the top of my head that the file name is pokemon.csv. And it's over here in the drive folder that you were linked to at this link. So I know it's named pokemon.csv, but if I try to run this, it's not going to work because it doesn't know where pokemon.csv is. This notebook isn't at all connected to this drive folder. So what's really cool is that essentially this notebook is running sort of on its own little server. And what we can do is we can upload files to it for its access. You can see there's a bunch of files here. This is essentially a Linux system. Won't go too deep into that, but essentially what we can do is just download these two files. All right, so I want you guys to follow along with me. You'll see this shared folder. I want you to download these two files, and I'll just add it to my downloads. And then this example is simply the example that I was showing before I went into the activity. So you don't have to worry about the example unless you want to look at those sort of commands that are outlined for you. There's a lot of comments in there for you to read if you want. But now that my download is done, it's in one of these folders. What I can do now is I can upload, right? So I can click on that upload button, go to my downloads, and you can see that these two files are here. I'll upload them. And okay. So now my files are in the file system of this notebook. So let's try running it again. And you'll notice it still doesn't work. And that's because we're missing this one character, this slash. And you'll notice it works perfectly when I put the slash. Why is that? Well, that's because this slash denotes a path. It's denoting the root path of the file system. That's how file systems in Unix work. Linux is based on Unix. And this path accesses that root, right? You notice that if I sort of go into any of these folders, right? A lot of these folders have folders within them, and you can get out, but you can't get out of this, well, I guess folder we're in. We're not even really in a folder. This is the root file system. This Pokemon.csv lives at that root. So we want to access that root by denoting the slash. If you don't have a slash, it's simply what's called a relative root, right? It's simply accessing wherever this notebook is. Now, I don't really know what folder this notebook is in right now in its own little environment. So what I did was I uploaded the files on the root of the file system so I could conveniently access it using the slash. Now what I'll do is I will store the results of this command into a variable called Pokemon_CSV. And I'll do the same thing for that JSON file that we also got, right? Equals pd.read JSON. And then remember that slash because our files are in that root of the file system over here next to all these other folders. And I want to now do Pokemon-JSON.json. if I run that, you notice great. No errors seem to have been found. And if I try to, let's say, print Pokemon_JSON, you can see, great, we have some data. So just make sure to follow along with what I've done. You should have your files in your directory now. You should have used the read CSV and the read JSON methods on the PD object, which we got over here as we imported pandas, the library. And now let's go on to that first task. So we want you to record your answers in Markdown. So what you're going to do is you're going to run your code. You're going to type your code here. Code. Let's say everything ran perfectly and I got a nice answer. I'm going to double click on this cell to edit it. Hit enter for that new line. And then I'll just record my answers. So for 1, let's say I got the answer 42. 42 Pokemon types in the data set. And for question 2, let's say I found 2 Generation 6 Pokemon in this data set. And for question 3, max HP was 20. Right? So that's sort of how we want you to record your answers. You write your code here, which I'll go through with you for the first little activity, subtask. But I want you to write your answers here, denoting the question number, so 1, 2, 3 for questions. And same thing over here. You have your code. Looks like task 3 is not asking for any Markdown, so you can just write your code. But task 4 does want you to use Markdown. So your Markdown over here. We have linked you to a cheat sheet for Markdown. And yep, so task 5 also has a Markdown cell. Double click. Some good old example answers in there. And then, of course, we've got some great resources. So back to that first task. What are we trying to do? I'm in this code block here. This is where I'll be running the code. And I want to find the number of Pokemon types in the data set. Now, the data set it's talking about is the CSV. Well, actually, now that I think about it, I think we can use any data set that we want. I'm pretty sure they're the same data set, except the CSV is going to be a lot easier to work with than a JSON. And that's because if I open up the CSV, you can see it's structured very well. Got the name, type 1, type 2, total, HP, attack, defense. Whereas if I open up the JSON, you can see it's sort of laid out in the opposite manner, where the CSV sort of has the categories straight out. In the JSON, the categories are a level deep, right? Where the categories are specific to each Pokemon. Whereas in the CSV, each sort of Pokemon is really just a row that has multiple columns associated with it. So when answering questions about data, CSVs are most likely the way to go, most often. JSON is good when you want to store a lot of data as objects. The JSON name itself stands for JavaScript Object Notation, and it is the notation that JavaScript uses to define and reason about of its own objects. Just so happens that it's a really great sort of format to store data in. So Pokemon, since Pokemon have sort of defined traits, they have a HP, they have attack, they have defense stats. It's really great to sort of store in an individual object representing an individual Pokemon, if that makes sense. So for task 2, we do want you to use the CSV. You may use a JSON if you want, if you can figure it out, but I'll be going through that first subtask using the CSV. So we want to find the number of Pokemon types in this data set. So let me just open up the CSV again, and you'll notice that, all right, I have a type 1 column, have a type 2 column. It's pretty cool. You can see there's some duplicates. So probably want to get rid of the duplicates. And we just want to find the number of them. Okay. If we remember back in that little example, right? There was a method called unique that I sort of brushed over really quick. If I go back to that example, you can sort of figure out how it's going to be used over here. So you can see within the example, it sort of gives you the answer to that first task immediately. We have our little Pokemon CSV object / variable. We are sort of indexing it at that column, right? So we have square brackets that are typically used to index lists. But in this case, Pokemon CSV isn't really a list. It's called what's called a data frame. And it's a specific type of data that Pandas uses to reason about with CSV files, JSON files, any type of data really. But we can index specific columns of data with it. It's really cool. And then on those columns, we can run methods like unique to get all those unique values. So let's try that. Let's quite literally just copy this code over here, run it here, and see what happens. So you can see we got some nice output. And we have the types, and there aren't any duplicates like we saw in the actual CSV file. So if we go back to that example, you see that there's a second method, nUnique, that shows the number of unique values in that column. So let's put that n in front. So what happens? 18, right? So showing us that there's 18 unique values in that type 1 column. So great, there's 18 types, right? That's settled then. Well, I would say not quite. You can see there's a type 2 column here. Now, even though it might be unlikely, there's still a chance that there might be a type in the type 2 column that doesn't exist in type 1. There's no way to know for sure. And as data scientists, we want to know a lot of things for sure. And this question is just one example of that. So what I'll do is I'll make a new variable called type1. And you can see I got rid of that n because I don't want the number anymore. I just want the actual values, right? And then I'll make a type 2 variable, and I'll do essentially the same thing. But instead of indexing at type 1, I'm going to index at type 2. And then what I'll do is I will just first try to print out type 2. Okay, so we got poison, and then this is a weird nan thing here. Now nan stands for not a number. The reason why that's coming about is you can see some Pokemon, such as Charmander, Charmeleon, don't have a type 2 value. So Pandas is looking at that sort of a null value and simply converting it to this type called not a number. That's what the NaN stands for. So we got to keep in mind that that's not an actual type. Just kind of have to ignore that. But ignoring it, we have flying, dragon, ground, grass. Okay. What about type 1? All right. Now it's definitely a different layout, and it's kind of hard to tell just by flipping through. If I try to print type 2 here, you can see we can sort of, get a sense of, all right, there's poison, not a number we have to ignore, right? Flying, dragon. So I can kind of sit here and compare each one and see if, every type in type 2 has a corresponding one in type 1. That would mean that both lists contain the same number of types, and we can just say for sure there are 18 types in total. Now that's definitely an option, but as data scientists, we are looking to do things in at least sort of efficient ways. So looking at these two lists manually and comparing might not be the best use of our time. You can probably do it a lot faster and also learn something along the way. So now what I'm going to try to do is I'm going to try to sort of create one big list, right? So let's see, type 1, 2. As sort of I'm going to make this new variable, and I want it to contain the combination of type 1 and type 2. Now, if I print out this new variable, you can see that, I can't really just add these two data frames. So what I'm going to want to do is I'm going to want to convert these to lists. This is a very common method in Pandas to essentially convert a data frame, a Pandas data frame, into a regular old Python list. Now you can see type 1, 2 has a combination of those types. And then what I can do is print out the set of type 1, 2. What set does is it converts any kind of given Python list into a set which cannot contain duplicates by definition. So if I run this now, I get only the unique values. And you can see NaN sort of made its way through, so we kind of just have to ignore that. If I take the length of this by wrapping it in the len function, I get 19. Now remember, the NaN type was there, so we have to subtract it by 1 because it's not a type. And we get 18. So yeah, in retrospect, all that work sort of was in vain. Didn't really have to do it. There was always 18 types, but it's good to be thorough. And we learned some things about sets, about adding data frames, or about how you can't add data frames and how you have to convert them to lists before you do any sort of list operations on these. Well, all right, that's that. Since we got the sort of 18 answer, I'm going to want to update my markdown here. Say 18 types of Pokemon. Great. And since these answers are all bogus, I will get rid of that. And, time to work on task 2, but I will leave that up to you students. Hopefully you learned a lot watching this video. Again, if you're not too familiar with Python, we do have resources linked on the website over here. Go to weekly activities, scroll down. We do have a video linked for Python. As always, Google is your friend. So anytime you have a question, just type that exact question into Google. 90% of the time, you'll get an answer. 95% of the time, you get some kind of answer, but you have to do some more digging. to figure it out yourself. And that sort of 5% of the time, Google won't really give you a satisfying answer, and that's what office hours are for. So come to office hours if you're having trouble doing really anything. And yeah, that's Jupyter Notebooks. We have the example file here in the drive that you can open up. Make sure you have the Google Colab thing installed. And seems to be about it. Great. Thank you so much, everyone. Hope you learned a lot. I'll see you in my office hours if you have any trouble. Thanks.